All right, hello everybody. Today we're going to start talking about an advanced programming topic called recursion. Okay, and this will be something that's not just specific to Java, but really any programming language we can use recursion, we can write recursive methods. Okay, what we'll do is we're going to split this into two parts. Okay, in the first part, we'll just talk about how this works, kind of work on tracing through some codes. And in the second part, we'll actually get into writing recursive methods together. Okay, so let's get going with that. All right, I'm going to say that recursion occurs when a method calls itself, as in the code within a method refers to the method that it's in. Okay, so when a method calls itself. Let's take a look at a bad example of recursion. Okay, so consider the following recursive method. Okay, we'll say public void run, and run takes an int as a parameter. Okay, now what does run do? Looks like run prints off that parameter x. And then what does it do next? It calls run. Okay, well, run is the method we're talking about here. Since it makes a call to itself, we'd say this is a recursive method. It's going to basically add 1 to the x you passed into the original run and then call at run once again. Okay, like I said, this is a bad recursive method because it's going to do something not so good here. Okay, so the question is, what will this method call output if I put in run 1? Well, my x is 1, so it's going to print 1, and then call run again on 1 plus 1 as in 2, which will print 2. And then 2 plus 1 is 3, so it's going to call run on 3. You'll print the 3, call run on 4, print the 4, call run on 5, print the 5, ... continuing like that. And what we're going to end up with this method, it's going to break Java. We're going to have something called a stack overflow. Okay, so we have in this case not only an infinite method that's not going to stop, that's okay in some cases. Okay, we actually have one that breaks Java. We'll talk about why it breaks in a second. But in other words, this is an example, a bad example of recursion. You don't want to do something like this, writing a method that never ends and breaks Java. Okay, why will this method break Java? Well, remember Java, when we make method calls, it stores the info for those calls in something called the stack. Okay, when you call a method, an activation record for that method is put into the stack with spots for all the parameters being passed. So with Java, we always start with the main method, so we always have some room in the memory for that. Okay, and the way this last method runs is the main method makes a call to run 1, which calls, so run 1, which prints 1 and then calls run 2, which prints 2, then calls run 3, which prints 3, then calls runs 4, okay, on and on forever. And what's going to happen is Java is eventually going to run out of memory, okay, for storing all these different method calls. Okay, run 1, for example, when I call that, it never quits running. It always stays there because as run 2 runs, run 1 is still running. And as run 2 is still running, run 3 is still running. Okay, so these build up on and on forever. And again, eventually, no matter how big and fancy of a computer you have, we're going to run out of memory. Okay, so this is different than just making an infinite loop in a program where we could say while true, print hello. Okay, that would print hello forever, but it's never going to run out of memory. Okay, when we actually have a recursive method like this, okay, that could actually kill Java if we run it incorrectly. So to write a recursive method correctly, that's not going to break Java, okay, we must have a stop condition or a base case, we could call it. That's going to be something that actually makes the recursive calls at some point quit. Okay, so the recursive calls will continue until that stop condition is met. So let's take a look at a slightly better run method, okay, with that base case right here. So this method is going to do the same thing, taking an int, okay, print that value, but then before I actually make the next call to run, it's going to check and see the base case. In this case, that's if x is greater than or equal to 5, rather than calling run on the next value, it's just going to return and kind of kill the chain of recursive calls. So as that goes, again, if I call run 1, it's going to print the 1 and then check the base case. So it's going to print and then check. Okay, x is not greater than or equal to 5, so we'll do the run x plus 1. That'll print the 2. Okay, check again. We haven't hit the base case yet. So we'll print the 3 because we just called run on 3. Print the 4. Okay, and then as x becomes 5, we will print 5 here. Okay, we'll check. If x is greater than or equal to 5, we'll just return. All right, so that's all the farther that this method's going to go. Okay, so to make a recursive method work correctly, again, without breaking Java, we need that base case. So let's take a look at how kind of this works out differently from a stack perspective. Okay, the main method calls run 1. Run 1 is going to print 1 and call run 2, which prints 2 and calls run 3, which prints 3 and calls run 4, which prints 4 and calls run 5, which prints 5 and then returns. Okay, so run 5 returns as in that method is done. So that will disappear from our stack. Okay, once run 5 is done, run 4 is now done. So that will disappear. Okay, and as each of those methods finish up, we'll get back to our main method, which will eventually, once it runs its course, disappear and we'll be all done. Okay, so from a memory standpoint, that's a big difference. Instead of adding to that stack forever, eventually we're going to quit and start eliminating things from that stack. Okay, let's take a quick look at that same run method with a slight difference. Okay, this time rather than having my print statement at the beginning, I'm going to have it at the end. Okay, at the beginning it was pretty simple, just printed 1, 2, 3, 4, 5. What's this method going to do? Well, if I plug a 1 in, we'll check the base case. Same thing, x is greater than 5. Or else we'll run the x plus 1. And when I call this run x plus 1, I'm actually not going to get to this print statement here. It's going to run x plus 2, or it's going to run the x plus 1, the run 2, which will check the base case. Not true, so we'll run x for 3, we'll run x for 4, we'll run x for 5 when we hit the base case. So what's actually going to happen with this one is my print statements aren't going to happen until we get through all the method calls and start returning. So what this one's going to do is print things in reverse order, 4, 3, 2, 1. Okay, because my methods are going to actually print reverse rather than printing right away, they print at the end. Again, from a stack perspective, what's going to happen here is we call run 1. What does run 1 do? Well, it calls run 2 before it prints. Okay, so before we can get to that print statement of 1, we have to run all the way through run 2. And same idea, run 2 is going to run all the way through run 3 before it prints. Okay, and on up the line until we get to run 5. All right, the way we had that set up, run 5 is just going to return without printing anything. So now once run 5's done, we're done with this step in run 4. We'll print the 4. Okay, run 4 is now complete. So we can do the last step of run 3 and print the 3 and on down the line. That's why that one prints in reverse order. All right, so the big thing we want to get down today is just how these recursive methods work. We'll get into actually writing our own in the next part of the lesson, okay, in the next video. So for the rest of the way, we're just going to work on tracing our way through a few different types of recursive methods. Okay, so the first one we have is a method called fun, which returns an int, and it is recursive because we are calling itself within that method. And we want to know what fun of 5 is equal to. In other words, what it returns. Okay, well, let's go through this. We plug it in int, and if that int y is equal to 1, we're going to return just the 1. All right, that's our base case. All right, or else what we'll do is we'll return fun of y minus 2 plus y. So in other words, we could say that fun of 5 is equal to fun of 5 minus 2 to be 3 plus the y, the 5. So if I want to know what fun of 5 returns, I first need to figure out what fun of 3 returns. Again, reading through that, if I plug a 3 in, we're not going to satisfy our base case. We're not going to return 1. We're going to return fun of 3 minus 2 plus the 3. So in other words, fun of 1 plus the 3. Okay, and then moving down the line, what is fun of 1 equal to? Well, when y equals 1, that is my base case, so I'm just going to return a 1. So I know what my base case gives me. And now what I can do is I can start working back up the line. Since I know what fun of 1 gives me, I know that fun 3 will be a 1 plus 3. In other words, a 4. Good. Okay, so I now know what fun of 3 returns, which is 4. I can now figure out what fun of 5 returns. It is the fun of 3, which is a 4, plus 5, which gives me a 9. All right, so what does fun of 5 return? It returns the 9. Okay, tracing our way through that method. All right, let's take a look at tracing through one more of these, again, slightly more complicated methods, where this time what we're going to be doing is printing rather than just returning something. Okay, so public void weird1 of string. We want to know what weird1 outputs if we plug in ABCD. Okay, so what I'm going to do for a printing case is, let's say I have weird1 of ABCD. And then what I'm going to do at the bottom here is I'm going to keep track of what we're printing out. We'll kind of build that print string one chunk at a time. Okay, what does this method do? How does it work? Okay, well, if the length of our string we plug in is less than 1, we'll return 1. Okay, so that's our base case. If not, we're going to print the string s. So right off the bat here, I'm going to say print A, B, C, D. And then we'll call weird1 on the string, the substring of 1. So in other words, starting at index 1, going through the rest of the string, in other words, we're going to lose everything but the first, or we're going to lose the first index of that string. So weird1 is going to give me weird1 of BCD. Okay, because the substring starting at index 1 going through the rest of the way of ABCD would be BCD. Okay, so let's figure out what weird1 of BCD gives me. Okay, well, its length is not less than 1, so we're not going to return. We don't hit the base case. We're going to print the string. So just kind of add that to our print stream here. And then again, what we'll do is we'll chop off the first letter by calling dot substring 1. So that's going to give me a weird 1 of CD. Okay, so again, we'll call weird 1 of CD. Okay, what is that going to do? That's going to print the string, so that'll give me a CD. And then we'll chop off a letter once again. Okay, and then what does weird 1 of D do? Okay, well, the length is still not less than 1, so we're not going to return yet. We're going to print that D, which is going to call weird 1 of the empty string. Okay, I have nothing. which will just return, okay, because that is our base case. Okay, the empty string here has a length less than 1, in other words 0, so we'll return. All right, so this will be what gets printed out by this method here. Okay, so if you're working with methods that print rather than return, I'd recommend kind of keep track of things that print as you go. All right, so there you go. That's how recursion works. The homework for this lesson is just tracing through some different recursive methods. So get a piece of paper out with a pencil, keep track of your steps as you go. That's really not too bad. Okay, again, the goal today is get a feel for how it works. We'll get into writing recursive methods with our next part of the lesson.